All right, now we're going to look at ways that you can combine functions. There's the main four operations that you're used to doing: adding, subtracting, multiplying, dividing. In any of these, you are just taking whatever the functions are and then adding one with the other and combining like terms, or subtracting them and also combining like terms. If you're multiplying, then you are oftentimes doing some kind of distributing and multiplying out and see what you get, and then again combine any like terms. Dividing, you take whatever the function is on top and divide it by whatever the one is on bottom. When you are doing these operations and they ask you for the domain is going to be the intersection of f and g. So what that means is if you have two groups of numbers that work for function f and numbers that work for function g, whatever the overlap in those domains are, that is going to be the domain of the combined function. The one thing with dividing, though, however, remember that your bottom function cannot equal 0, otherwise you have whatever numbers make that equal 0 don't work in the function as well. The one other way that you've looked at combining functions besides the four main operations is composition of functions. That's where you have one function inside of the other. There's two main operations that you see with composition. This little open circle symbol means composition. So it means f composed with a g. The way it's written more often would be this, where you have function f with function g inside of it. What composition means is whenever you have parentheses, you work inside out. So the most inner thing here would be g. So actually it'd be x. So you take your input, you run it through function g, see what that does to it. The output would be g of x. And now you have this outside function of f, so now you're going to run that new result of g of x through f, and once you run it through that function, out would pop f composed with g. So what our goal is instead of having to go through two functions like that, just come up with one function that can get us from that input to the output in one thing rather than having to do it twice. Any of these ones, the composition, the domain of the new function is the domain of g that also fits within the domain of f. All right, so let's try some of these operation problems out where we're combining. Up on top, there's three different functions, f, g, and h. We're going to do some operations with those. So the first one wants us to add f and g. This right here means the same as f of x plus g of x. It doesn't mean add the two functions and then times by an additional x. It just means add the two functions together. So if we look up top, there's those two functions. We want to add them. And so it's going to be x minus 2 plus x squared plus 3x plus 4. Since there's a plus between these problems, our parentheses aren't really doing anything here, so you don't necessarily need those when you're adding. I put them in there to kind of distinguish between the two we substituted in. Now it's just combining the like terms together. There's only one squared term here. I'm going to do that one first. We got two terms with x to the first power, so adding those together would be 4x, and then we get these two constant terms that would add together to be 2. And that would be the addition of f and g. Subtraction. Again, this notation here means we're taking f minus function g. So we want to make sure f comes first, and it is important in subtraction that you get them in the right order, minus this other function. With this one, again, the order does matter because the second function, and we do need it in parentheses here, because everything's going to need to get subtracted there. We got to change the signs on all those. And so this is going to end up being x minus 2 minus x squared also minus 3x, and also minus 4. All those have to get subtracted. Now we do like we did in the last problem, combine like terms, and we get our solution. We got a negative x squared. We got x minus 3x, so minus 2x. And then we got a negative 2 minus 4, that would be minus 6. That would be the result of the two functions being subtracted. Let's look at some multiplying, dividing now. Again, f and g are two functions, so same two functions we were just dealing with. If we multiply them, we're doing x minus 2 times that one. Here parentheses are again important because we're multiplying, so here you're going to have to distribute. X is going to have to get multiplied to each of these. After we're done with that, then we got to distribute that negative 2 to each of these. So we should end up with 6 total terms after doing all that. So x times x squared is x cubed plus 3x squared. All these are going up by x. Now we're distributing a negative 2. Make sure you get the negative with it because it's minus 2. So minus 2x squared minus 6x, and negative 2 times 4 is going to be minus 8. Now to finish, look for like terms. I think we only got one cubed term. We do got 2 squared terms here. We got 2 x terms, and we got our constant of negative 8 at the end. So that would be the multiplication of these two functions. With division, we're looking to divide them. The function on bottom here is f, so that would be our x minus 2. The one on top is our x squared plus 3x plus 4. With these ones, the only way you can simplify is if something factors. The bottom doesn't factor. We could look at the top. Does anything multiply to 4 and also add to 3? I don't think we have any combinations that work there. So nothing's factorable, which means nothing needs to be simplified. Now, the last thing they ask for all these is what is the domain. So let's go back and figure out the domains of these. When looking at these functions up top, polynomials, their domains are all real numbers. We looked at that all real numbers symbol before. And so here, remember, it's the intersection. Well, if you have all reals and all reals, the domain of that one should be all real when we get to our answer down here. Going back with the adding, subtracting, same thing. So the domain of our new one should also be all reals here and here. What about, though, the division one? Well, this would also be all reals. However, since we're dividing, we got to check the bottom. Is there any values of x that don't work here? Yeah, the one number that's not going to work here is 2. Because if you put 2 in there, you're going to get 2 minus 2 is 0. You can't have division by 0. So the domain for this one would be x, where x can't be positive 2. So that would be the domain for the division one. All right, composition. Now we're dealing with some functions within functions. So this first one, f composed with g, another way of writing that is f with function g inside of it. And so what we're going to do to write this one out is start with function f. It's the outside one. So this, whenever you got f, it's going to be something minus 2. And what we're going to do then is place inside of the variables of f the whole function here. So this whole function is going to end up replacing our variables here, because f composed with g, we know function g right here is also this, so it kind of becomes like f composed with this function inside of it. So you got to replace all the x's with that whole function. So the x gets replaced with x squared plus 3x plus 4. Now to simplify that, all we got to do, it looks like, is combine our two like terms here. There's nothing to distribute on this one, so it would just be x squared plus 3x plus 2. That would be the composition of those two functions. The next one is also composition. Same two functions, but different order. So now this one is talking about g composed with f. So we're going the other way on this one. Now we're starting with g, which is this function. So anywhere there's a variable, there we're going to be replacing it with something new. And what we're going to replace it with is this function. So anywhere there's a variable, we're going to replace it with a x minus 2. Okay, how do we simplify that one? Well, there's some distributing here. We have a term squared, so we're going to need to multiply two of those together there. And then do a bunch of distributing. So let's figure out what we get there. So we're going to do FOIL on that. X times x is x squared minus 2x minus another 2x plus 4. Here we have a 3 we're going to distribute. So plus 3x minus 6. And then we get that plus 4 at the end. Now the last step, just combine together any like terms and see what you get. We only have one squared term. We got 3x terms here. That's negative 4 plus 1 would be negative x. And then we got our 3 constant terms, which would add up to. So that would be the composition of G composed with F. Notice, are they the same? No, you get different things depending on which way you compose them. So they most often would not be the same here. All right, we got one last one. This one is F composed with G composed with H. So another way of writing that one would be like this, which means we have a function within another function. So this one you got a composition of 3 functions. Again, start with let's just start with finding one of here. What would be this one? Let's start with that. What's G composed with H? So what we're going to do here is start with this one, and then replace any x's there with the function here. So that's going to go in there and go in there. So I'm just going to find that one first. So we're going to have G composed with H here is going to be something squared plus 3 times something plus 4. That something we're putting in is that x plus 1. So just like before, we're going to go through and simplify that out by distributing and doing all that stuff. This whole one, if you do x plus 1 times x plus 1, you're going to get x squared plus 2x plus 1. Here you got to distribute the 3. And then the last one, we get that plus 4 on there. Combining like terms, then we end up with this. All right, so that's G composed with H. So if we know G composed with H equals this, that could replace this here. So now what we got to find is what is F composed with this result. So now we're going to take that result, plug it into function F, and see what we got. Function F is something minus 2. So if we take something minus 2 here, the something we're putting in is this. So we got x squared plus 5x plus 8. And if we minus 2 from that, the overall composition of this function ends up being right here. That's the composition of 3 functions. That would, on its own, do the same thing that taking x, running it through function h here, output would be h of x, then running that through function g, out would pop g composed with h. Then take that, run it through function f, and then out we get f composed with g. Composed with h here. So rather than having to do all that, this function on its own would skip right from here to here. All right, last thing with this, they wanted what is the domain for each of these. With this one, it's like what's the inside one that fits within the outside one. All these again are polynomials, so they're all reals. Which means all our answers here should have the domain of all real numbers as well. All right, last one here. Why don't you pause the video and try this? Actually, no, this one's a little bit different, so we'll try it together. This one, you have a composition, but instead of X's, you got number here. That changes a little bit. You can still do it the same way and then plug the number in, meaning we could still find what's F composed with G of X. And then once we find that, plug a 4 in and see what the result is. Otherwise, we can also think of this as what is F composed of G at 4 and work inside out to get our answer. So the first thing here, what is G at 4? We could find G at 4 by coming up here and plugging 4 in and finding out what that number is and then go from there. So we could easily use your calculator, just run that through. That's going to be 16 plus 12 is 28, plus another 4 is 32. So if we do all that, 16 plus 12 plus 4 and get 32 here, G at 4 is the same as 32. So if we just replace this now with a 32, now our function looks like this. What is F at 32? Well, we can go over here and figure out F at 32 by just plugging it in. 32 minus 2 would be 30. So the overall result of this is 30. So if you're doing these composition with numbers, it actually becomes a little bit easier. You just have to figure like one part out at a time until you get the answer. Subtraction, they want us to subtract these two. Remember this means what's F at 5 minus G at 5. You could figure out both those individually and then just see what the result is. So F of 5 would be 5 minus 2 or 3. G at 5 here. Plugging 5 in, you'd get 25. Plus 3 times 5 is 15, plus 4. That's 44. So now you just got to do what's 3 minus 44. Negative 41 would be the result. Division, same thing. If you got to find this division of these, find them both separately and see what you get. In the top, you plug 2 in the bottom, you plug 2 in. However, looking at the bottom one here first, if we find F of 2 here, you get 0. So this one does not exist because remember what our domain was for this one. I think we had this one before. X can equal 2 here for this domain, so that's why this one does not work or does not exist.